Hi, so my name is Jessie, and I did some research into mental health in the technological field. So, an introduction to this project was I wanted to learn some new topics, go over some of the things that we didn't do in our homework. We went over things like K nearest neighbor, and we did some decision trees, but we didn't do anything with multi-class neural networks. In fact, we never even talked about it in class, and we also didn't have any project at this point about ensemble methods. So I wanted to do my attempt at boosting because bagging made a lot of sense to me. It seemed pretty easy. I wanted to challenge myself and to understand boosting better since I wasn't completely clear on it in the beginning. So my topic was mental health in the workplace, in the technological workplace, and this came from a 2016 survey asking people questions like their age, their gender, if they worked in the tech field, were they self-employed, how big was their company, do they believe that their employer offered mental health benefits. So why I went over this was the importance of mental health. Mental health is a huge part of who we are as people and how we conduct ourselves in our daily life, and a lot of time mental health kind of gets swept under the rug. So if we could find a way to discreetly reach out to people who may or may not be predisposed to needing mental support, then we would be able to get them that support they needed without potentially jeopardizing their image or anything else that prevents them from currently reaching out for help. Now, this could also go the other way and cause employers to have a method to figure out who might be predisposed to mental health disorders and fire them, get rid of them. So this is a very gray area where the research discovered in these projects could be used for good or bad. So there's a lot of related work as well, related work in the mental health field amongst general practitioners in general, amongst a bunch of different jobs. There's also research into self-employed workers, into women's mental health in the workplace, and the data set that I'm looking at had a 2014 survey, and there had been a lot of Kaggle research as well on this topic, including who may be predisposed, the same kind of research that I planned on doing, only in the 2014 survey with different questions. And then the 2016 survey, there's been research into what factors correlate to people who reach out to get mental help, to figure out what factors influence people to reach out the most. So my approach, the first thing I knew I had to do was I had to prune the data, because there were a lot of people taking the survey who did not take it seriously, including putting random answers into fill-in-the-blank responses, so I had to prune all of those out. I wanted to, as I said before, do a multi-class neural network. I initially wanted to just do a neural network, but when I realized that my output class that I was looking at had 3 values, instead of giving up on a neural network, I really wanted to challenge myself to see if it was possible to create a multi-class neural network. And not only was it possible, there had already been research done on it, and I was able to follow along with that research and teach myself the material. I wanted to do an ensemble method because it was something we'd covered in class and not something we had actively built ourselves, so I wanted to get the practice in and familiarize myself with it as well. Again, boosting because bagging already made sense to me. I just wanted to challenge myself. In the end, I ended up doing bagging as well because it was simple enough to do in a couple of minutes. So the first thing I had to do with the data was a lot of the data had multi-answers for each attribute, so I had to turn this into binary data so I could filter it into the neural network. In doing so, if a question had multiple answers, yes, no, maybe, each answer became its own attribute, and then I would have a binary value in place for whether or not that answer showed up for a specific instance. Again, I had to filter out the nonsensical answers and people who were just not taking the survey seriously. So I set it up pretty close to the way I planned it out. In fact, I think everything turned out the way I had planned it after I realized I needed to do a multi-class neural network. I was stuck initially when I realized I was going to need a multi-class neural network, but I was able to do, I think it was about 3 days of research and reading different blogs and different people's codes to understand how to build a multi-class neural network, and specifically how to build a softmax multi-class neural network that instead of outputting the answer for which class the instance was most likely belonged to, it outputted a percentage of how likely that class was to be part of that instance, and then I was able to translate those percentages into a specific class. And then again, I did bagging and boosting. So my results. I was able to get a 61% accuracy in predicting whether or not someone would need mental health support. Well, that's not the score I was really focusing on. I was focusing more on my false negative rate, as it's more important, it's more costly to fail to give someone mental health support that needs it than to accidentally suggest mental health support to someone who doesn't need it. So my false negative rate was 13%, which is higher than I would like it to be, because that's still 13 out of 100, every 100 employees not potentially getting the mental support they need. So if this was something that would be implemented in the workplace, it would also need a supplementary material as well to make sure we covered that 13%. So I don't believe that this is something that could be implemented in the workplace. It has too high of a fail rate and too low of an accuracy to cover who we need to cover. So it was a decent result, but it wasn't great. It was a lot more in learning the material than it was in the actual results of the survey. So again, conclusion. I learned a lot. I learned a ton about neural networks, how they work, because the neural network I had to build had to have a hidden layer in between. So we had, instead of a linear division, we had a potentially non-linear division because I knew the data would not be linear. I assumed the data would not be linear. And while the results were lackluster, it was certainly worth the experience because I learned so much from it, and I feel a lot stronger in my material for both ensemble, bagging and boosting, and neural networks.